Hello viewers, in today's session we are going to find out the value of this definite integral. So here we have to evaluate the integral from minus 10 to 10. We have cot inverse x dx, right? So here let us first call this integral as I. Now here we can use two methods to find out the value of this integral, but here we'll discuss only the first method, right? So in the first method, we'll make use of the method of substitution. So let us make this substitution, that is x is equal to minus t, right? So the purpose of making this substitution is to make use of this uh, identity, that is cot inverse minus x is given by pi minus cot inverse of x, where x belongs to the set of real numbers, right? So we'll take x is equal to minus t, so that dx over dt is equal to d by dt of minus t. So this is minus 1, so we can write dx is equal to minus dt. So let us change the limits accordingly. So when the lower limit is minus 10, then the corresponding value of t is given by substituting x is equal to minus 10 in this expression. So we have minus 10 is equal to minus t, so t is equal to 10. And when the upper limit is plus 10, then the corresponding value of t is given by 10 is equal to minus t, so t is minus 10. So when x varies from minus 10 to 10, t varies from 10 to minus 10. So let us now write this integral I in terms of t. So we have here 10 to minus 10, and cot inverse of x is minus t, and for dx we can now write here minus dt. So now let us simplify this integral using this property of definite integrals, that is a to b, and f of t dt is equal to negative of b to a f of t dt. So when we interchange the limits, the value of the definite integral is negative, right? So here we can neutralize this negative sign by interchanging the limits. So we can now write minus 10 to 10, and we have cot inverse of minus t and dt, right? So we can now write minus 10 to 10, and cot inverse minus t can be replaced by this expression, that is if we apply this identity to cot inverse minus t, then we can write pi minus cot inverse t, and here we have dt. So let us write this expression as minus 10 to 10, we have pi dt, and then we have minus 10 to 10 and cot inverse t dt, right? So now we have I, and we have now two integrals. So here we can take pi outside the integral, and we have minus 10 to 10 dt, and this integral is now equal to I, because here we can again make use of one important property of definite integrals, which says that the integral a to b f of t dt is equal to integral a to b f of x dx. So this is the dummy variable property. If we replace the variable t by x, then the value of both the definite integrals remains the same. So here this integral can now be written as I. So now taking this minus I to the left hand side, we have I plus I, and here we have pi. The integral dt is simply t. So here we have t, and limits are from minus 10 to 10. I plus I is 2i, and here we have pi, and substituting the limits and taking the difference, we have this expression. So now we can write 2y, and we have pi and 10 plus 10. So this is 2y is equal to pi times 20. So I is 20 pi over 2, that is 10 pi, right? So the value of this integral I is equal to 10 pi. Now, here it is interesting to note that the value of this definite integral can also be obtained by using this identity, that is cot inverse x plus tan inverse x is equal to pi by 2 for all x belonging to the set of real numbers. So we can replace cot inverse x by pi by 2 minus tan inverse x, right? And then applying the property of definite integrals, that is for odd functions, that is minus a to a, f of x dx is equal to 0 if f of x is an odd function, right? So using these concepts, we can also arrive at the value of this integral as 10 pi.